Create new script with name kinematic character.gd that extends from kinematic body. Set template to empty. Set class name to kinematic character. Create 3 vector 3 variables. Dynamic velocity will be used for throwing character around. Gravity velocity will allow character to fall when in air. Static velocity will allow character to move with steady speed. Create physics process method. This method will be responsible for applying velocities to current position, sum up velocities and apply movement to character. For collisions, create handle collision method that will be overwritten by child class. To apply gravity, first create gravity constant equal to 9.8 above the variables. Then create apply gravity method. Inside this method add gravity acceleration to velocity vector with direction pointed down. You don't want gravity to grow indefinitely, so create will collide with floor method. This method will be overwritten by child class and will tell the script if the applied movement will end up in collision with the ground. Back in apply gravity method, you have to check if character with new gravity velocity is going to collide with the ground. If yes, then set gravity velocity to 0. The script takes dynamic velocity to calculation because though gravity velocity might be 0, dynamic velocity could be pointed against the ground, and then the applied movement of the character would look bad. To prevent this, the script sets dynamic velocity on y-axis to 0. Back in physics process method, add call to apply gravity before the code for applying the movement. As established earlier, the dynamic velocity is for throwing the character around, but we don't want character to fly indefinitely when thrown. It would be good to add some fake air friction. The easiest option to add something like this is to add velocity damp. Every second it subtracts a specified portion of current velocity from the velocity. To implement this, first create velocity damp constant after gravity constant. Normally the value should be between 0 and 1, but for this the value of 1.9 works great. Now create apply dynamic velocity damp method, and in it subtract a portion of dynamic velocity specified in velocity damp. Back in physics process method, call the apply dynamic velocity damp method, right after apply gravity method. As you can see, this class is made to be extended from by the actual character script. The character has to change its velocity vectors somewhere. It would be bad if it was changing them in overwrite in physics process method, because we could change something in this method in the future, and it might break logic of the script. To prevent this, create manipulate velocities method that will be overwritten by the child class, and all velocity changes will be made inside this method. Call this method after calling apply dynamic velocity damp method. There is one thing, apply dynamic velocity damp method has one problem. When velocity is very small, then it takes a lot of time for dynamic velocity to go to 0. It can also overshoot and oscillate around vector with length of 1. To prevent this, create minimal dynamic velocity constant, which will be a threshold, below which dynamic velocity is equal to 0. And after manipulate velocities method call, make condition for setting the dynamic velocity to 0. Create apply impulse method for applying impulses to the character. Inside it, just add velocity to current dynamic velocity. To handle bouncing off stuff that the character is colliding with, create bounce method, that would change direction of dynamic velocity, and subtract a bit of this velocity specified by the absorption value. Now let's see how it works in practice. You can bounce off the world objects thanks to bounce method. It bounces very far, but you can change the absorption value to be higher. This would make the bounce distance smaller. It works in 2D too. With this logic, it's easy to make character controller. This is the script that controls the character in 3D. It has its problems though. Gravity velocity grows indefinitely when character is in air, and this can cause problems. It is easy to fix though. You can for example set gravity to 0 when you don't want character to fall. I use 2 raycast, but you don't need to. In 3D I use only 1 raycast. It tells will it collide method if the character is on ground, and is very useful for other stuff. I try to jump as fast as I can, but the gravity overpowers me. Another problem is that gravity oscillates when character hits the ground. Here, the value is 21, then 0, then goes to 4, and then to 0, and so on until it finally gets to 0. It's not a big deal though, but it can annoy when you want to use gravity in animation tree. You can fix this easily though. In the character controller, fall animation is fired up when gravity velocity is greater than 0. Because it oscillates, it's buggy. I fixed it with raycast by checking if the player is on the ground. Links for the stuff are in the description of this video.